Hello students, welcome to my YouTube channel RD Academy. So in this video we will be learning about a new concept known as electric flux. Okay, so before I teach you about electric flux, there are some prerequisites that you need to know beforehand to understand this concept of electric flux. Okay, now the first among them is something known as area and area vector. Okay, now what do you mean by area? You already know it is nothing but the uh, length into breadth. If you are considering a rectangular object, the area of this rectangular object is length multiplied by the breadth. Now one question I will ask you, is this area a scalar or a vector? Okay, so if you are looking at it from the mathematical perspective, that area is just a scalar. It's just multiplication of two numbers, length and breadth. But whenever you deal with the area in physics, the area is a vector quantity, or in more general or in more precise way, the area element is a vector quantity. Okay, now what is this area element? Out of this whole area, if I only take a small element, then that is what I call it as area element. Okay, and this area element is a vector quantity. Okay, so the first one is done, area. Next, area vector. See, every area has something known as area vector. Okay, and area vector is always perpendicular to given area. Okay, so to show that for you, I have a small piece of cardboard here. Okay, now ignoring this extension, if you consider only this small portion, okay, it is in the form of a rectangle, right? The length is this part and breadth is this part. So this is your area. Now what will be the direction of area element? Now inside this bigger rectangle, I will only consider small rectangle of this dotted region. Okay, what will the area direction of area vector? Now always remember, area vector is always perpendicular to given area. So if you have area vector lying in this way, suppose this is xy plane. Okay, this entire object is lying in xy plane. The direction of the area vector is always perpendicular. That is, it will be like this, in the direction of this pen cap. It is coming towards you. Okay, so which direction is that? If you consider three dimension, the area is in xy plane, the area vector should be in z plane. Okay, the area vector is always perpendicular to the given area. Now there are two directions, right? One is it can come towards you like this, or it can also go into the plane of the paper. So that's why every area element has two possible directions. Okay, that we will call it as, one is plus n cap. Whatever it is coming towards the observer, it is also always known as plus n cap. The other one moving away from the observer, it is known as minus n cap. Okay, so always remember, if you consider any area, the area vector is always perpendicular to the given area, like this pen cap. Okay, it is coming towards you. Area is here, but the area vector is coming towards you. Similarly, what happens if you rotate the area like this? Initially it was like this, right? Now what happens if you rotate it like this? The area vector will be in this direction, moving from left to right. Okay, so this is one of the important point. Area vector is always perpendicular to the given area. Now coming to the definition of electric flux. So the electric flux is represented by the symbol Greek letter phi with the subscript E. Okay, I will tell you to develop the habit of writing this subscript E here only. Okay, because whenever we start to deal with magnetic field, then we have something known as magnetic flux. That also there also the symbol is Greek letter phi, but the subscript we use is B. B is used to represent magnetic field. Okay, so it should be phi, and this should be subscript. Okay, don't write it like phi times E. This is the wrong representation. It should always be phi should be the bigger letter and E should be the subscript. Fine. Now assume you have a point charge. Now we are discussing about what electric flux actually is. Okay, now assume you have a point charge. How will the electric field lines look like for this point charge? For a positive point charge, the electric field lines are radially outward in direction and they extend in all possible directions, right? Now at this particular point, if I have an area A vector, your electric flux tells you how many field lines are crossing this effective area. That area you can take anything, you can take 1 meter square, you can take 10 meter square, anything. Okay, that electric flux tells you how many field lines are passing through this area like this. It is known as the electric flux. Okay, and the mathematical expression for that is given by electric flux of a electric flux is equal to dot product or scalar product of electric field, magnitude of the electric field, multiplied by the area vector. Now remember, this area is a vector. Which will be the direction of the n cap? It will be, this will be plus n cap, this will be minus n cap. Okay, so the electric flux is nothing but dot product of two vectors. Which are the two vectors? Electric field vector and area vector. Now in first year you have already learned the definition of dot product. A vector dot b vector, I can write it as magnitude of the vectors multiplied by cos theta. Similarly here I can write it as magnitude of electric field, magnitude of area multiplied by cos theta. What is this theta? Theta is angle between E vector and A vector. Okay, now assume here the angle between E vector, this is E vector, and n vector, area vector n cap is 0 degrees. So cos 0 will be 1. When will this theta have values? Now consider a situation like this. These are the direction of electric field lines. Instead of drawing the electric field like this normal to it, draw it at an angle. Now what happens? For this particular area vector, the electric field is in this direction. Sorry, area vector is in this direction, electric field is in this direction. This angle between the two vectors is what I call it as theta. Okay, so I hope I am clear. Electric flux is nothing but dot product of electric field multiplied with the area vector. Okay, if you want to understand it, just remember how many field lines are passing through a area you are considering. That quantity is known as electric flux. Fine. Now can you tell me the SI unit of electric flux? See, electric field, we have already seen the SI unit is Newton per coulomb. What is the unit of area? Meter square. So the SI unit of electric flux is Newton per coulomb meter square. Okay, now one homework for you, try to write the dimensional formula for electric flux. Okay, so you already know what is the dimension of force, dimension of charge, and dimension of length. Okay, just substitute it, simplify. So this is the explanation for electric flux. Okay, here always remember area vector is always perpendicular to the given area, which means if you have a area like this, the area vector is always perpendicular like this. It is coming towards you like this pen cap. If you rotate the plane like this, what happens? Here it will be there, it will be same. 1 second, it will be same, it will be like this. No matter however you orient, the n cap is always perpendicular to the area. If you rotate it like this, n cap will move in this direction. If you keep it like this, n cap is coming towards you. Okay, so that is the important point here, and this definition is also important. We will continue in the next video. Thank you.